Okay, Bismillahirrahmanirrahim. We come back. So these are a few properties of definite integral. For an integration for a boundary a to a is 0 because the area is 0. And then if we have the integral from a to b is similar to a negative of integrand from b to a. Okay. And if you have a constant, you can put in the constant up front. And then number 4, if we have the two functions, plus and minus only, okay, not multiplications, so you can split the f, integrate from a to b, plus or minus, split the g from a to b. This is only for plus and minus, not multiplication or division. And then if you have a boundary, integrand of boundary from a to c, you can flip, okay, such that it is a boundary a to b of the f plus b to c, and b is mid value from a to c. Okay, so b is middle value. Let us look at some examples. Okay, let's analyze example 1 given to us. Given that the integration function f for the boundary 5 to 9 being negative 4 and another function g for a boundary from 5 to 9 being 7. So let's find the integral from 5 to 9 of constant 5 times f plus g. So according to our principle just now, we can take the constant and then we can actually integrate individually like this, and hence we replace the value. Integral of f from 5 to 9 is negative 4. Integral of the g from 5 to 9 is 7. So we get the answer for this operation. Next, let's analyze question 2. Suppose that we have the f with the variable z, integral of 8 from negative 3 to 3 is 0, and the integral of f with respect to z from negative 3 to 6 being 3. So let's find the integral of a boundary for 3 to 6. For 4 of this f. Right, so again, playing with the property, we can split. Okay, so negative 3 to 6, we can split. It becomes negative 3 to 3 plus 3 to 6. Right, this one. And then for the f function of a negative 3 to 6 is given, which is 3. So, and the integrand of f from negative 3 to 3 is given, which is 0. And hence we are supposed to find the integrand from 3 to 6. So we can rearrange, we get this. So hence, to read it as a negative 4 of the f, we can put the negative 4 in front, and from here we get from this first operation, and hence we get the answer for what we have to find. Okay, let's do more example. So just now we see that for the integral of a boundary a to c, you can actually split, but the b that is between the a and c, you can separate them, another way to say, right? So, and then let's look at this 13, 14, 15, and 16. We're going to do it together. This is an absolute value. It's a symbol. You need first, before you integrate, you need first to define this absolute value symbol. So first start number 13. An absolute symbol of this can mean negative x or positive x according to the boundary. Okay, so we need to define it first before we are to do this question 13. So let's do it together. So as we define this absolute with the correct interval, it is a negative value for less than 0. So meaning for negative 2 until 0, 0 is between negative 2 to 3. Okay, so this function carry negative value. As for greater than 0 until the upper boundary 3, this function absolute carry positive. You have to define it first correctly. Okay, and then after that only you can integrate. Okay, let's integrate together. So we write down, okay, before we substitute the value, you can write like this. So here we have x squared onto for a boundary of 0 to 3. Okay, next we are to read the definite integral, replacing the x with first the 0. So we get 0 minus, and then replace the x as a negative 2. So there we have a negative, so negative 2 square over 2. Right, that's the first part. For this part now, replace first the upper boundary, which is 3. So we have 3 square on 2 minus, replace the x with the lower boundary, which is 0. Okay, let's solve this. So this is 2, this is 9 on 2. So if we are to add it up, so let me write down 2 plus 9 on 2. Okay, we can combine it such that this is 4 plus 9, which is 13 over 2. So that is the answer for question 13. Alright. Okay, next let's do 14 together. But first, yes, you have to define first this absolute symbol 4 minus x. Let me erase this first. So let's define first this absolute. Okay, when we are just merely to draw a line of 4 minus x with a negative slope, this is a straight line, and when x, for example, when the zeros, okay, when the y is 0, the intercept on x-axis is the 4. But when we are to get or to read this function as absolute, the y cannot receive negative. So what happens now? So our graph, as it touches 4, it will flip. Okay, so there is one way to draw the situation for a graph of absolute 4 minus x. So hence, we can define this function such that the value or the absolute symbol here, it can means that it is a this slope, okay, which is the 4 minus x, for x less than 4, and beyond 4, greater than 4, it will receive a positive slope. So in order to get that positive slope, we have to write down the negative. Okay, so another word for this part, negative of 4 minus x is similar to x minus 4, right? Negative 4 minus minus plus. So this part is 4 minus x. So that is the definition of the equation if we are to split it. Right? And then our boundary here is from negative 2 until 6. So definitely you need to separate it. Okay. So we need to define the absolute value. So this is how it looks like. So this is not without this symbol there. So that is the function that you need to recognize together with the boundary. Right. So this one must be correct first for that question 14. So in other words to say, don't straight away integrate with the symbol of the absolute. Right. And then after you have got that, okay, you integrate first. Help me. For x minus x squared onto, okay, with the boundary of negative 2 to 4, plus for this one x squared on 2 minus 4x for the boundary of 4 to 6. Okay, the correct integral. And then we replace the x with the upper boundary minus the lower boundary. So let me do it. So I've got that first part. We replace the 4 first minus, replace the x with the lower boundary. And then we do the same thing for this portion. Okay, so there is the second portion. Replace x with the 6 and minus replace x with the 4. And then you just use your calculator to finalize your answer. So I'm using a calculator. My answer is 20. Okay. Compared to your work, do we get a similar answer for it? Right. So that is the question number 14. That is how you should do it. Starting with defining first your absolute value and integrate. And then use the definitions of definite integral and your answer. So this type of a question can carry 4 marks. Okay. So up to now we have done number 13, number 14. Next, how do we define absolute for sine x? So in order to define, we have to know how is the functions of the sine looks like. Okay, so let me draw a simple function of the sine from 0 to 2 pi. And here we have a negative. Let's extend it to the back. So to define sine absolute, we need first to know how do the graph of the sine looks like. Here I'm playing with negative pi onto 2 pi. So whenever we have an absolute, the y cannot receive negative. So what happens is, for this portion from 0 to negative pi, we need to flip. So hence we'll get something like this. Okay, oops, sorry. So as we flip for this portion 0 to pi on 2, so we need to flip. Flip meaning for this graph for negative, for 0 to, for negative pi on 2 to 0, we flip the graph of the, we flip the graph of the sine. So we will receive negative. Okay, as we flip it. Okay, and then for this portion from 0 to pi, it is, you can just play around with it. So 0 to pi over there. So you don't need to flip. So you just remain as the original sine x from this above graph. So that is the graph of absolute sine x. And likewise, if you are extending the boundary of the sine x for beyond the pi, so from 0 to 2 pi, you can see that you have to flip it again. So you will receive a negative. You flip this function and you will receive a negative sign. Okay, for a boundary from pi to 2 pi, if you want to take it as 2 pi. But our question, we are just to analyze from negative pi on 2 to pi only. So, and again, before you integrate, you need to define first your absolute value. So in our case, we will have negative pi on 2 to 0. We need to separate it. So this graph will carry negative because we want to flip it. Okay. As for the boundary from 0 to pi, our upper boundary is pi, so we can just take as is. So that one must be correct first. Okay. Right. Then only we integrate. So we need to look at the formula list, how to integrate negative sine pi. Let's find the formula list. So here is a simple formula. So the integration of a sine is negative cosine. We're going to use it, okay, for our question just now. So we integrate that. Okay, so we get that. And then I'm using another color. And then we are to replace our upper boundary first minus the lower boundary. Okay, let me write it first. So I'm simplifying it first to become positive cosine. Okay, so let's replace the lower boundary. And then plus replace the upper boundary, cosine pi, minus replace the lower boundary, cosine 0. Okay, so we need to read the values of cosine 0, cosine negative pi on 2, which is 0, cosine pi, which is, cosine pi is what? Cosine pi is 1, negative 1, and cosine 0 is 1. So check my work. Cosine 0 is 1, cosine negative pi on 2 is 0, cosine pi is negative 1, cosine 0, cosine 0 is 1. Okay. So let's simplify our answer. So we have 1 minus 0 minus 1 minus 1. So be very careful with your integration. So check my work. Integral of the sign, I make simple mistake there. Okay, so which results, which will affect my answer. It's supposed to be negative, kan? Negative. So negative. So minus minus plus. Right. Okay, it should be okay. So what is our answer, y'all? What is our answer? Be very careful. My answer now is 3. 1 minus minus plus 1 plus 1 G. So that is the answer. Alright, so that is number 15. So I'm gonna leave question number 16 for you to do it. Okay, a similar function, but now this is more than pi. So this is 3 on 2 pi. So what happened for this graph? This is 2 pi. So you extend it further until you get 3 on pi. So do it by yourself. Let me write the answer. You can compare to my answer. So for number 16, you need to have 0 until 3 on 2 pi. So for this part, pi to 3 on 2, you need to flip. Alright. So inshallah, if my calculation is correct, the answer should be 3. Okay. Try it, okay? So pause the video and try this question number 16. I've given to you the answer being 3. Okay. So before you are to compare to my work, try it first. Let me give you about 3 minutes for you to try it. So what did you get? I got 3. Right? So compare to my work. Alright? Okay, let's do more.